And so if you wanted this to have any relationship to the geometry of the equipotential surface, then you would have to demonstrate that all of the points lie on the same line. And you haven't done that. And it doesn't seem to matter how often I repeat this to you. You just keep on telling me the experimental setup as though I don't understand it. I'm very confident I understand the experimental setup. It's not going to distinguish between different equipotential geometries, and you can go ask somebody else. And so if you wanted this to have any relationship to the geometry of the equipotential surface, then you would have to demonstrate that all of the points lie on the same line. So Bev seems to not. So I have an observation. Bev has not said that he is not recording this conversation. So at this point, I feel like my intellectual property is being stolen by Bev.
What?
What intellectual property?
Why?
Are you recording? Are you going to undertake that you are not recording this conversation?
Why are you fucking...
Okay.
So
Are you
Bev,
drunk right now, Tony?
I am asking Bev a direct question.
What?
Is Bev recording this
Of
conversation?
course it's recording. Always assume you're being recorded, Tony.
Yes.
Okay.
Always.
Don't take advice from
Sorry, you're right. You're right.
everything that they say is in vain.
But as you pointed out, I'm crazy.
Never take advice from fools. We all know what they do is in vain.
Then I'm out. Then I am out of here. Well done. Thank you, Bev, for invading my privacy.
What?
Did that make him leave?
Yeah.
Did he just bounce?
Yeah. He was tired. I mean, he'd been up all night, right? He's been up a long time.
Yeah, I mean, he did start to sound a little bit drunk.
Oh, it actually sounded
I
like
thought he was drunk, but I guess he's been up for like 24 hours. Or
He goes in a shouting bit and he gets tired after it. You can hear him. It must be tiring. They're doing all of that ranting and raging that he was doing.
I caught the brunt of that like twice. And plus he called me fucking what's up?
I've only been in here, twice tonight?
It's a good rest.
Yeah.
Never take advice from fools. 'Cause everything that they say is in vain.
Okay, fuck you.
Never take advice from fools. 'Cause everything that they do is in vain.
Maybe he has to go Betty buys.
Yeah,
Maybe
well,
he has
like,
to go sleep.
we came in here about 16 or 17 hours ago. And
Really?
yeah.
I think I was in here like 4 hours ago.
Yeah, we
So you
started
probably-
ages ago. Like we've done a massive shift. Like loads of
Oh wow.
Tony
Okay.
must have done 8, 9, even 10 hours, right? When did
I
Tony
went out
come
and
in?
played pool and drank with my brother and came back on. I was still going on a bliss.
Yeah.
Because the Earth is rotating to the east, there is a piling up of water on the western side of the ocean basins. This is called western boundary current intensification. And it is an observable phenomenon.
Don't take advice from fools. 'Cause everything that they say is in vain.
It's so depressing.
Never take advice from fools. We all know what they do is in vain.
The idea behind it is to show geometric proofs conceptually in real life with a water level showing connecting straight line segments
But
with
but
a water level with communicating vessel.
If the water level test you're talking about is putting a 2-point water level and another 2-point water level end to end, and a 3-point water level beside them, hoping to see no difference between the water levels in the centre of the 3 points at the ends of the 2 points that are together in the middle, and to then claim that as proof that there's no curvature. Then
Hold on. And yes, you may think I'm mentally unstable. Hell, you'd agree with my therapist, but I don't care anymore.
Don't take advice from fools. Everything that they say is in vain.
You may think I'm mentally unstable.
Never take advice from
Hell,
fools.
you'd agree with my
We
therapist.
all know what they do is in vain.
You need a straight line running through all 3 points. You need to demonstrate that all three water surfaces are in fact collinear, and you need to do it using something other than water level, because all you're proving with water level is that the water levels are at the equipotential surface. You're not constraining whether that equipotential surface is undulating or round or whatever. You're just, or flat. You're not demonstrating it unless you apply some external control. Does that make sense?
Plan to have to put it together for a couple more.
Then it's a very good plan, but without
Never take advice from fools. Everything that they say is in vain. Never take advice from fools. Everything that they do is in vain.
but without the laser demonstrating the straight line, it seems like this is not proving what you want to prove. That it's consistent with all available theories about the shape of the equipotential
See, I
surface.
think that's where the crux is, because it's not meant to show the shape of the Earth at all.
The observational campaign that Bev is proposing will not distinguish between a flat Earth or a spheroidal Earth or a donut-shaped Earth or any fucking shaped Earth, because the equipotential surfaces are going to match up in each and every circumstance. How hard is that?
I don't know. That's not what I was talking about. So, I mean, you're having a conversation with
Don't
yourself.
take
So,
advice from fools. 'Cause everything that they say is in vain.
I say
Never take advice from
to
fools.
see a bigger sucker.
We all know what they do is in vain.
good luck with that.
Okay.
I gotta keep going.
Okay, well, go on.
It's been entertaining, though. That's for sure.
All right, I'm glad I entertained you, and I wish you the very best in your day. And I apologize for saying you were what's up. The equipotential surface is a complicated shape. It's not circular. It's not flat. So you could be in a portion where the equipotential gradient happens to be parallel to ground level.
I got your numbers right here.
Sorry, you're right.
It's just
You're right.
as easy as 1, 2, 3. You have to open your mind.
But as you pointed out, I'm crazy.
Imagination is all you need. Don't take advice
What
from
Sugar Cookie
fools.
just said didn't actually make any sense
Everything
at
that
all.
they say is in vain. Never take advice from fools. We all know what they do is in vain.
You know, what you're doing will produce the same results, regardless of what the geometry of the equipotential surface is. But the
Water in
reality is,
imagine water in the ocean sense. It doesn't equate the same way, right? But the ocean isn't level.
Everything is relative to you.
it's just so disparate.
You just have to say it in generality.
It's so depressing.
Just like those straight lines are curving.
Okay, fuck you.
Where all of this goes. Never take advice from fools. 'Cause everything that they say is in vain. Never take advice from fools. 'Cause everything that they do is in vain.
You had the opportunity to constructively interact with me, and you decided instead that you'd be a fuckwit. Okay? Go ahead and be a fuckwit somewhere else.
Hold on.
Because however big a fuckwit you are prepared to be,
Game that you're playing.
I deserve
And
to
I
be a
know
bigger
exactly
fuckwit.
what's on your mind. You got your playbook, it's alright.
But I have to, well, you know,
Your model dictates what
so
you will
why would this
find.
occur if the earth is not spinning?
And I don't know where all of this goes. Don't take advice from fools, 'cause everything that they say is in vain. Never take advice from fools. We all know what they do is in vain.
No! You're now! You are now in the What's Up Club. But the equipotential surface will be the dominant effect on the length scales that you're discussing. Accept it and move on! Well, I mean, you're trying to establish, you can have problems with refraction. I do concede, but you can factor those out if you take accurate enough measurements of the vertical gradient in temperature.
We're gonna.
So if you've got measurements of temperature at the points between, let's call your first one A, your second one B, your second water level, and the middle one C. If you have sort of measurements of temperature as a function of elevation in between A and C and B and C, then you can make a stab at correcting for refractive effects. That's true. But you kind of need some demonstration, or you could just, you could try and demonstrate some sort of straight line between A and C. That's what you need to do. And check that it passes through C.
So are you looking at the first point? Are you standing at the first point and then looking at the last point?
Yep. And you want a straight line between those two that coincides with water level in the intermediate, because my contention is that they'll coincide in terms of equipotential surfaces, but you haven't proved the equipotential surface is flat. If you draw a flat line, a straight line from point A to point C, and you show that, point A to point B, and you show that middle one is on the level of that straight line, then you've gone some way to demonstrating it. Again, you would the equipotential surface is a complicated shape. It's not circular. It's not flat. It's got a complicated structure to it. So you could be in a portion where the equipotential gradient happens to be parallel to ground level. And in that case, you kind of need to do this experiment in lots of different places to demonstrate your results, but you definitely need that straight line between the first and the last in order to demonstrate what you seem to want to demonstrate.
So kind of like looking down a pool stick. Like you ever play like billiards? Like looking down a pool
Mhm.
stick and see if it's straight.
Yeah, yeah,
Well, that's silly.
that's right.
That's kind of silly. Then.
Is it? Why?
Well, yeah. Well, because you're looking at it like, how are you going to determine where your horizontal is?
You don't need to determine horizontal. All you need is for the point in the middle to coincide with a straight line between the two levels.
Right.
So as long as the levels are in line of sight with one another, just point the level from one side, point the laser or whatever, or string or whatever you want to use from one side to the other side, and make sure that it passes through the meniscus at both ends.
How do you
You've
account for
got
angular, like
yeah,
angular sight?
I mean, there are a lot of. This is the problem with what I think you're doing is that there are a lot of impediments to accurately establishing your result. It's not that I think that what you're doing will produce the same results, regardless of what the geometry of the equipotential surface is. And so you need to have some external
When you say,
control to just.
well, when you say, the potential of the surface, the water level doesn't matter. It doesn't care what the
No,
ground
it does.
is doing.
Yeah, that's absolutely
No,
true.
it doesn't.
It
That's how you
only
get
it only it only it only cares about equipotential surfaces. Yes, it only cares about the shape of the equipotential surface.
No,
Right?
no, that's not right.
All right. Why is it not right?
Because you can figure out how much your house floor, your foundation is settling by using a water level to see how far below or above your measuring stick is from the horizontal of the water level.
Okay. So are
The ground
you
beneath
claim? So
the water will be level no matter what.
So are you claiming that if you built a house that was 200 meters wide, you would have a dead level floor for all 200 meters that was absolutely straight?
Yes.
Okay. Then I suggest that you do
That would be
that.
useful.
I suggest. So here's the thing that we keep on butting up against in this conversation.
And the other thing is with the water level, you don't have to have line of sight with it. I could go around the corner, and I know that the level in that tube of water will be the same level as the other end.
It will be at the same equipotential surface, and you are relying on the fact that the equipotential surface has not changed much in in your transit around the corner. That's how water levels work.
If I dug a hole and I stuck the pole that's attached to the other end of the water level tube, I stuck that pole in the tube, or I'm sorry, that pole in the hole. The water level in that tube will remain level with the water level in the other room.
Okay, you remember how we talked about sea level previously? Can you guys do me an immense favor and look up the term Western boundary current intensification?
What is that? Can you give me some
So,
context?
so these are ocean currents that occur on the western boundaries of oceans.
Are you talking about mean sea level?
Sure, why not?
No idea.
Sure, why not? Yes,
Okay,
we're
water
talking
levels
about mean
are
sea
not
level.
the same thing as sea level.
Okay, so let's just talk about Western intensification. You should have been directed to a website about oceanography. Because the Earth is rotating to the east, there is a piling up of water on the western side of the ocean basins. This is called Western boundary current intensification. And it is an observable phenomenon. You know, it's just so dispiriting. Right? It's so depressing that I have to
This sure does
that
seem
I
like
have
a
to
non-sequitur.
that I have to well, you know, so why would this occur if the Earth is not spinning?
Yeah, I'm just gonna have to say this is a complete non sequitur now.
Okay, fuck you.
Okay.
You know,
Okay. All right. Whatever.
the motion of it, the geometry of water surfaces is more complicated than you imagined. That doesn't seem like that fucking difficult a concept for you to internalize. But you've managed to fucking obstruct and fucking say, nah, enough, that I'm done. Right? I'm just going to fucking yell at you until you fuck off and shut up and start writing something, you useless fucking sack of shit. I'm no longer interested in being polite to you. There are multiple ways of detecting water levels, and all of them, each and every fucking one of them, is consistent with a spherical spinning Earth. And I was hoping that Western intensification would be some indication that you had no fucking idea what you're even fucking talking about as far as water level is concerned. But no! Instead of you saying, oh, well, there's something I hadn't heard about that makes me rethink my understanding of water levels, no! Instead, you're off to the fucking, well, this guy obviously doesn't know what he's fucking talking about. How about you go away and fucking read up on this shit? No! 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 You're now! You are now
you're not
in
gonna
the
get away with
WhatsApp.
it.
You are now in the WhatsApp club. Well done. You managed to get there. You have graduated. You have graduated to the WhatsApp club. Fuck off and learn something. Fuck off and learn something. Go and fucking read up on some fucking physics. You ignorant fucking waste of biomass. You burden. You fucking deadweight social loss. You are the walking deadweight that your family is embarrassed to talk about. No, you have abdicated. You have abdicated your right to speak without me shouting you down. You had your fucking chance. You had your fucking chance to listen to what I had to say. And at no point in this exchange whatsoever have you listened to a single thing that I fucking said. You didn't listen to me about earthquakes. You didn't listen to me about gravity. You haven't listened to me about water level. You haven't listened to me about sea level. You haven't listened to me about... Shut up! Shut up! You haven't listened to me about GPS. You haven't listened to me about the shape of the Earth. You haven't listened. You haven't listened to a fucking thing I've said. No, I'm going to keep talking, and you can try talk over me. You can try speak now, but you've abdicated your right to because you've shown that you've got no interest in truth. Interest in truth is the fundamental basis of, yes, I'm going to keep on yelling. I promised I'll keep on yelling for the next 2 hours, 3 hours, 4 hours, 4 hours. Yeah, I'll keep on going. So truth is the basic element of reality, and you've shown that you've got no respect for truth. You have done. You have compiled observations. You have compiled observations that are meaningless. You have compiled You have compiled observations that are meaningless. They do not mean what you think they mean, and you are ascribing. You like Bev are ascribing. You are ascribing a meaning to your observations that your observations do not warrant. And you will not listen to me when I say this. You will not listen to me when I correct you. You will not listen to me when I show you that reality is vastly more complicated and there are vastly more observational data sets that we have available to us than the one that you are absolutely fucking desperate to restrict the conversation to. Right? You want to talk about water in pipes. Water also exists in canals. It exists in lakes. It exists in oceans. And you need the same theory to apply to all of them. You need the same theory. You need the same theory to apply to all bodies of water. And you are not willing to listen to the fact that actually there are influences on water level that are more complicated than you have taken into account. You will not listen to that. You don't care. Okay, you don't care. Then fuck off! Fuck off! Go away! You don't care about reality. You don't care about reality. Okay, you don't care about reality. That's okay. Not everybody has to care. There's no law that says you have to be right. You can be wrong as much as you want, as long as you do it somewhere the fuck else. Okay, go and do it there. Because I'm not going to let you do it here. I'm not going to let you try and infect other people with your mendacious, delusional worldview. I'm not going to let it happen. And yes, you may think I'm mentally unstable. Hell, you'd agree with my therapist, but I don't care anymore. You have literally, I came into this trying to explain stuff to you, trying to explain stuff that I spent fucking decades learning and mastering. And you have not responded with a scintilla of intellectual honesty on your side of the discussion. You have lied, you have obstructed, you have misdirected, and you have mischaracterized everything I said.
Not true. Any of that.
Yes, it is true. Fuck off. You had your chance.
So you're doing the uh-huh.
Yeah, I am. Like you had you had the opportunity to constructively interact with me, and you decided instead that you'd be a fuckwit. Okay, go ahead and be a fuckwit somewhere else.
Hold on.
Because however big a fuckwit you are prepared to be, I'm prepared to be a bigger fuckwit.
I'm not what's up.
Okay.
This is the entire time, dude.
So, yes. What do you want to say?
Well, that's what I'm saying is I'm just trying to talk to you about how water levels go. And then you're bringing up the ocean tides. I actually looked it up, what you said.
Yes.
And I was like, so that's how
water levels respond to multiple influences. And they coincide, they don't even necessarily coincide with equipotential surfaces, they respond to forces other than that, like Coriolis forces,
Wait a second.
like
This
tides, like
hold
winds.
on.
Like, for fuck's sake, can you not admit that this is something more complicated than water levels are just fucking flat?
Can we go back a couple steps? Like the whole time you were yelling there, you thought I was what's up?
No. I thought you were the fuckwit who was telling me that I was non sequituring. Are you the fuckwit who was telling?
We're non sequitur.
Okay, you're being a dick.
No, that's not what's up.
Okay, water level responds to stuff other than the equipotential surface. But the equipotential surface will be the dominant effect on the length scales that you're discussing. Accept it and move on.
All right.
Do you have a meaningful question? I mean, you guys, you keep on going, well, I'm just asking this, I'm just asking that. Well, I've answered this fucking question a million times. The observational campaign that Bev is proposing will not distinguish between a flat Earth or a spheroidal Earth or a donut-shaped Earth or any fucking shaped Earth, because the equipotential surfaces are going to match up in each and every circumstance. How hard is that?
I don't know. That's not what I was talking about. So, I mean, you're having a conversation with yourself. So, good luck with that.
Okay.
I gotta get going.
Okay. Well, go on.
It's been entertaining, though. That's for sure.
All right. I'm glad I entertained you, and I wish you the very best in your day. And I apologize for saying you were what's up.
Yeah, you motherfucker.
Yeah, sorry.
That's okay, sorry, Dan. I'll let it go.
I can only say I deeply regret it. But, yeah.
I'm saying water levels don't have anything to do with ocean tides. Deal with it.
Well, I mean, that depends. That depends on how accurately you measure them, because there are tidal effects in freshwater bodies. There are tidal effects in the atmosphere. In fact, we can detect the deformational signal. So
I'm not talking about lakes. I'm not talking about canals. I'm talking about
even in a water level, gravity has an effect.
I don't know much about water levels either until I researched it and got one and did my own little experiments with tubes and shit.
Okay, so I would suggest to you, please, again, you don't need to listen to me, but go down to your local university and ask them if this experiment is going to distinguish between a flat Earth and a spheroidal Earth.
No, it's not. I don't think that. I don't think that.
Just ask them that.
Experiment, or test, or whatever you want to call it. I don't think that's the purpose of it anyway. So I don't know why I would ask that, but whatever.
Okay, so can I ask what do you intend this observational campaign to demonstrate? What are you hoping this will prove?
Well, it's already he already did it.
Yeah. What are you hoping it proves? What do you think it proves?
Well,
do you think it's inconsistent with the sphere Earth?
No, I don't think there's anything to do with the shape of the Earth.
Okay. What do you think it proves then?
Well, I think it proves that there are straight line segments from taking geometry from 2D and conceptual into the 3D world.
How did you establish the straight line between the first and the last of your level?
Because there's
and how did you demonstrate?
I didn't do it.
Okay.
I saw it done because it was
without a straight line between the two that coincides with water level in the intermediate, then it doesn't demonstrate the straight line between them, right?
When I put in there like communicating vessels, right? So there's two. There's actually only two water levels. Each one of them has four different points on it. The first point, the second point, the third point, and the fourth point.
What's the fourth point? Sorry, I'm not following you.
Well, you
I
still want me
thought
to
there were
fuck
the
off, or
two.
you want me to tell you about it?
No. You can tell me about it. Sure, why not?
Okay. So did you look at, I think before Bev showed you a picture of the model of what the test was going to be.
So
I don't
yes,
know
it
if you had
has
a chance to look
multiple.
at it.
It has multiple
Yeah.
transparent pipes in each of
So,
which there is a level.
okay, so you get the general idea. So on the
Yeah.
left-hand side, there is one, I guess the first end of the tube.
Mhm.
And then there you go 200 meters to the right, and there
Mhm.
is another, there it is. He just posted it in the chat.
Yep. I see.
All right.
Yes,
So
that's very.
that first
Thank you,
one,
Bev.
yeah, so the first
Very.
one, the first vertical on the left goes
Mhm.
all the way over to the uh, furthest one in the middle. And it also has so if you say A, B,
So there's
C,
a connection.
D, and E.
Yeah. He's.
So
Yeah.
A
Yep.
is
Okay.
A goes to B, and it's connected to C, and it's connected to D. So that's what I was saying earlier about communicating vessels.
Yeah.
So
Okay.
those are all filled up with water.
Okay.
So then
So.
you go take the one on the far right. That one is
Mhm.
basically a mirror image of the one on the far left.
Okay. All
Yeah,
right.
Bev posted
Yeah.
another diagram for you to look at.
Yeah. So the.
And so there's both of those are have I guess 1, 2, 3, 4 verticals that are all connected. So
Yep.
you see that overlap there, right?
Yep.
So that overlap is probably better visualized in the second one that he posted there. You can see where those
Okay.
straight line segments are connecting.
Yep.
So from the left to the right, and then from the right to the left, those are all connecting in straight line segments.
Mhm. Yeah. Yep.
So does that answer
Yeah.
your question?
Uh, so I don't have a question. I have an observation, which is to say that you've described you've described your setup to me. My response to it is that it would give the same results regardless of the shape of the equipotential field.
Absolutely correct.
Okay, so
The ground below it doesn't matter.
well, the equipotential field is only loosely related to the shape of the ground beneath it, but
Well, that's the thing.
you
That
need so.
let me stop. Can I stop you right there real quick?
Sure.
Okay, so imagine that the I guess the ground in that example had bumps and hills in it below that, like that 2x4. It wouldn't matter because the water would still equal out to level.
Yes. This is the thing where we try explaining what the term level means, and you keep on sort of refusing to believe us. The two points are at the same elevation or at the same level if they lie on the same equipotential surface.
Okay, yeah, I mean you
Right?
can say that. That's fine. Yeah, that's fine. You can totally say that.
And so the relative levels between the various columns of water in the various pipes is going to be dependent on the shape of the equipotential surface. And for instance, if I put a really, take a portion of neutron star, for instance, and I put it under the right hand nozzle, that's going to pull water level down relative to everything else. But the other water levels, the level of water in the other pipes is going to be affected differently. But you're all going to end up with an equilibrium situation where there's a level associated with it. There's an equipotential curve going through. And so if you wanted this to have any relationship to the geometry of the equipotential surface, then you would have to demonstrate that all of the points lie on the same line. And you haven't done that. And it doesn't seem to matter how often I repeat this to you. You just keep on telling me the experimental setup as though I don't understand it. I'm very confident I understand the experimental setup. It's not going to distinguish between different equipotential geometries. And you can go ask somebody else. Like at this stage, you've asked me this often enough that I'm tired of repeating it to you. Like this set of observations, as meticulously implemented as it might be, is in no way indicative of the shape of the Earth or the equipotential surface.
Yeah.
I'm sorry.
So that's not I don't think that's the point of the
Okay,
demonstration.
then what is the point of the demonstration?
To show.
Tell me what you're trying to demonstrate.
Well, I thought I did at the beginning, but
That
basically,
they lie in a straight line, but you failed to introduce
are you gonna interrupt me and
a
yell at me
straight
again, or
line.
do you want me to continue
Sorry,
try to explain it?
sorry. You're right. When you're
Okay.
right, you're right.
Okay. I'm not gonna beat you over the head with it.
Please do.
All right, Simon and Dan, just give me a chance real quick, okay? So the idea behind it is to show geometric proofs conceptually in real life with a water level showing connecting straight line segments with a water level with communicating vessels.
Okay, how have you demonstrated the straight line? To me, all you've demonstrated is
we know water levels are a tool to establish a horizontal.
So in which case you are axiomatically assuming that the equipotential
one
surface
assumption is not complicated.
Well, yes, but I don't agree with your axiom. And if I substitute for it a different axiom about the shape of the equipotential surface, your experiment still works. So your experiment has failed in its objective to distinguish between any two equipotential surfaces, and it will continue to fail to distinguish between the two unless some external validation of geometry is applied to it. And I don't, again, you can say I'm wrong, right? And I have no doubt that you will say I'm wrong.
All I'm saying is that that's the point of having two separate ones.
Yeah, but you really need something like a laser or something that is in a straight line. Two separate ones isn't going to guarantee you the independence. So if I say that, suppose you set up one network of three, and I tell you that all three of those are going to be coincident with the equipotential surface, and you say, well, there's another set of three. Now we should be able to tell the difference. Well, no, that other set of three is also in equilibrium with the equipotential surface, and it's the same equipotential surface as the first set. So you haven't actually achieved it. You haven't.
It's a shared straight line segment.
Except, well, you're asserting
do
that
with
it's a
what they
straight line.
prove.
You're asserting that it's a straight line, but you aren't demonstrating that it's a straight line. And in order to get anywhere, you need to
Well,
show me.
that's why I said there is one assumption that
Okay, but that's an assumption, and if again, in order to be, in
one
order to
assumption.
be,
That's it.
in order to be indicative, yes, but it's the one assumption that makes it consistent with every other possible geometry, right? I can substitute any fucking geometry for the equipotential surface I like, and all of your results are going to be consistent with it.
When you say
And so the observational setup, if you want to validate your claim that they are all in a line, you need to prove that assumption is
if I want to
correct.
prove it to you, then what should happen?
Okay, you only need one set of three. What you need to do is set up a laser level from the first to the last. That
wanna
is,
look at
yeah, I want to look at it. So the water level. All I need is a laser level with appropriate measurement, with appropriate constraints on refraction, because that can be an effect.
So you want to
So,
eyeball a water level with.
so I want a laser. I want a laser that is coincident with the meniscus of levels 1 and 2, that passes through the meniscus of the level in between them. That's what I want, and I want appropriate constraints on, and I want this to be applicable everywhere on the surface of the Earth. That's what I want. I want, well, not necessarily everywhere. At multiple different locations on the Earth, I want the same experimental setup, and I want the same result.
Okay.
Right? Because
that's the plan is to have to put it together after a couple more.
Then it's a very good plan. But without the laser demonstrating the straight line, it seems like this is not proving what you want to prove. That it's consistent with all available theories about the shape of the equipotential surface.
I think that's where the crux is, because it's not meant to show the shape of the Earth at all.
Well, but it does. The shape of the equipotential surface is different from the shape of the Earth, right? The equipotential surface
the ground below
is the
water level doesn't have anything to do with how level the water level is.
It's got to do with gravitational potential, and if you don't understand gravitational potential theory,
for example, hold on. Hold on. Let me get my thought out. So, for example, if those tubes were much longer and they were all wiggly on the ground, it wouldn't matter.
No, it wouldn't. It wouldn't really matter. No.
Right. That's what I'm saying.
Yeah.
When you say the equipotential distance of the
it's not it's not distance. It's not the distance between them. That's the issue. It's the shape
potential of the water level doesn't matter how far those tubes are going around underneath, moving up and down.
Yeah, that's right. That's right. The water level at the top is always going to coincide with the equipotential surface. Right. The gravitational potential of both water surfaces is going to be approximately the same. I mean, there are frictional effects, air pressure effects, so it's not going to be exactly the same, but it's going to be approximately the same.
Tony, we've come a long way from you telling me to fuck off and yelling at me to having a conversation.
Yeah, that's true, and I apologize. Perhaps I went off, but if you're going to go down this path, and I honestly think you're not going to prove the equipotential surfaces are flat, but if you do, fair enough. I kind of think I kind of think that this effort, I kind of think that this is, I kind of think that this is your lifespan here on Earth that could be more constructively spent doing something else. But
I'm sure you could
if you
probably
want to, if
than
you,
talking.
yeah, I almost certainly. But as you pointed out, I'm crazy, so I'm here.
I mean, I'm not
talking
the
to
only
you.
one.
Yeah. So you can do this, but without sort of the laser or the external validation that there is a straight line connecting the tops in all of the pipes. All you're basically just saying water surfaces conform to equipotential surfaces, which we know already. So
All right, then why are you fighting it?
yes. Well, I'm not fighting it. What I'm saying is that I don't think you're going to demonstrate what you think you're going to demonstrate
It's all just
with this experiment.
shared straight line segments. That's it.
You're assuming that it's straight line segments, but you haven't demonstrated it. This
Well,
again gets
I'm
back to the point
like,
you have not at this point demonstrated straight line segments. You need a straight line running through all 3 points. You need to demonstrate that all three water surfaces are in fact collinear, and you need to do it using something other than water level, because all you're proving with water level is that the water levels are at the equipotential surface. You're not
Yeah.
constraining whether that equipotential surface is undulating or round or whatever. You're just, or flat.
just
You're not
shared
demonstrating it unless you apply some external control. Does that make sense?
I mean, you're talking about a bunch of external stuff, like
Yeah.
tides. Is that where we're going again?
No, it's not tides. I just want you to have a laser that runs through the 3 meniscus surfaces that demonstrates that they lie on a straight line. That's all I want.
Okay, well, fair enough. There's one
And
assumption, and that assumption is that the tool of a water level establishes a horizontal plane of reference. And that
yeah, and
is one
except that,
assumption. There's not an assumption that Venus is the same size of Earth. It's not some crazy, there's no complications. That's just it.
yeah, but
It's simple. The
but it's
simplicity
but
of it,
it's
I think, is really good.
but it's while it's an assumption that fits with every conceivable equipotential geometry. I assume that equipotential surfaces actually do gigantic gigantic oscillations with a wavelength of 1 meter. The water level isn't going to be able to tell the difference.
You want to put a laser on it? Is that what you want to do?
Yes, that's what I want to do, is put a laser on it. And remember please to check with.
You can totally do it. It's just some tubes of water.
Okay, so
everybody can do it. That's the whole idea. It's like it's super easy and cheap for people to do for themselves.
So this is
I
the
don't
thing.
have a laser, but
To me, I started studying earth sciences when I was
I know you're ancient.
And I'm now 53. So I spent the last 3 decades.
You got me back.
More than 80, on average.
You're basically almost
dead. Yeah, I am basically almost dead. But on average, 8 hours a day for the last 33 years, I've been examining spherical geometry and the observational validation for it, and the fit between the observations and the theory. And that's what my life is about. It's about minimizing the observation between the misfit and the theory. And trust me, in 33 years, if I thought that, a simpler, much easier to implement geometry, which is what I spent my entire PhD studying, was a more effective investment of time, then I'd have gone there. And And it just I've spent multiple decades studying the shape of the Earth and its gravitational field, and it
sounds like
bewilders me.
you could probably speak out
And
a little bit better.
and it bewilders me. Well, certainly when I meet you, I wonder about the value of that, because it doesn't seem like that has any value to you whatsoever.
It's not
Like
necessarily
it doesn't.
a challenge
It,
or a threat to your life's work.
well, no, absolutely, it's not. I mean, I'm happily employed. I get paid, hundreds of dollars an hour to do what I do. And obviously, no flat earther is going to get paid to do what I do. I know that. My
Not
objective
that
here
shouty
is,
stuff, right? You
I
don't
mean,
get paid for
I
that.
mean,
Yeah.
I mean, my objective. No, I mean, my objective here is to stop people from pissing their lives away. Like, all I want is for people to stop wasting their lives. Is there corruption in science? Yes, absolutely. Is there corruption in government? Yes, absolutely. Unquestionably. Is the political system in the United States, almost dysfunctional because of the level of corruption involved? Yes, yes, it is. I believe in all these things. But, that doesn't justify leaping to the conclusion that all of science is lying to you. Like, it just seems like the most bizarre conclusion to come to. And
Yeah, I'm not
my
sure that
objective is,
I haven't
how
said anything.
about we all
Hey, man,
focus
hang on,
on
tell
the
me-
real.
Hold on. I haven't said any of that, dude.
No, but other people have. How
Okay,
about we
well,
focus? How about
I'm
we
not representing
focus our efforts?
you.
How about we focus our efforts on real problems? Okay,
Like,
real areas of understanding. Like, how about we do that instead of everybody wasting their time and energy on this fucking nonsense, right? It's intellectually, this is completely fucking absurd, right? I mean, you
No,
have to
I actually
construct.
don't think so. I think one of the things that I think is very
You
intellectually
believe
stimulating is contemplating and talking about and discussing the environment and the realm in which we live. So I don't think
you believe that pictures from space taken in
So-
1963. You believe that pictures from space taken in 1952. Sorry, I'll correct myself. Were CGI'd.
I didn't say that, and that's not what we're
Okay,
talking
well then, what is this about? Like, what is this debate about? You apparently don't believe the Earth is flat, and
no.
apparently you don't trust professional geodesists.
You're gonna start
The-
yelling at me for no reason.
The study of the shape of the Earth, its rotation, orientation in space, and its gravitational field has a name. It's called geodesy. Geodesy, and it has been an intellectual pursuit for hundreds of years. And my question is, why are you trying to reinvent the fucking wheel? You seem to accept the science. You seem to accept the science behind your computer easily enough. You seem to accept the science behind.
I'm gonna have to stop you there. You're arguing things that I'm not even talking about right now.
Okay, what are you talking about?
Okay, let's bring it back home. Okay, we're just talking about the water level test and taking geometric
Why do you think?
and then
Why do you think?
That's it.
Why do you think this is constructive? What do you think this will achieve?
Well, I think it's a very interesting thing to take something conceptual and bring it into reality.
Okay, except that I am telling you.
Hold on. Was the water level test a conceptual thing or a reality thing?
No, geometry is a conceptual thing.
Yes, it
So-
can be. Yes,
Right,
but
right.
also
And so taking those
right,
concepts and then bringing them
right. They
into
can
real
be
life,
conceptual.
something that can
right?
be demonstrated.
Yes.
Yeah.
So
like-
were the water level tests conceptual or demonstrated?
the water level test that that Bev has done and that I watched
Bevan
on his
spot on.
Discord that he did, yeah, with spot on. It brings it into real life, into reality.
A conception into
reality?
real
So it
life.
takes a 2D, yeah, it takes a 2D line and brings it into reality with a real life tool.
Except
water
you
level.
haven't demonstrated that it's a 2D line. And
Well,
I don't,
That's what I'm saying,
so
bring conceptual into reality.
Well, I would
except
also,
you haven't.
I would also beg to differ over the water tests. Were always level, like water is level, even through the water is level test is they tried to do this in the early 1900s, right?
They did
So
it way before that. Yeah, way before that.
well, in the 1800s as well. Yes, yeah.
Well, the pyramids were, I think, they say were built and leveled with water level.
The floors of Egyptian temples, they used water levels. What they would do is they would build the framework that they wanted to put the floor
I
in.
think they probably used plumbers more than anything else.
No, we can actually can people listen to me, because I know the details of this. They would build a rectangular brick, a brick edifice in the shape that they wanted. They would fill it with water. They would pour ink onto the water, and then they would let the water out. And then they would use the level marked by the ink on the inside of the bricks to determine what level they should build to. And you can even tell, on the basis of this evidence, where the wind was blowing from when they did this exercise.
No, because it'll be more up on one side of the wall than other sides of the wall. Yeah.
Sure, I guess that's one way to do it. Basically, like a swimming pool. A small.
Yes, that's right.
Swimming pool, right?
Yeah.
So, but there are multiple ways to use a water level, and I didn't realize this until I actually got one and
That's really interesting, by the way. Yeah, super interesting. I didn't know about that. Putting ink across water that would float on top of the water.
They were clever that way. What can I say?
Yeah. That's pretty ingenious, actually. Yeah, pretty ingenious.
Basically, if you get a milk jug, fill it full of water, and you have a tube attached to it so that it doesn't leak out, you attach the other end of that hose to, say, a piece of trim with a measuring tape taped up to it. What you do is you just look at where that water level is, and on the other end of the tube, you get your measurement. And that way, like if you, for example, there's a guy I saw that was figuring out how far his foundation had settled in his house. So what he did was he just took the water jug and he went around. He's like, okay, got his basically zero measurement.
Oh, he got his level by using the water jug, off the.
Well, not the water jug. The water jug was stationary, but the measuring stick, you could go around room to room to room and see what the difference in that elevation was from that water level from the milk jug. And you say, okay, well, 2.5 inches in this room, 3.5 inches in this room, or whatever it was, and he'd mark it all down, and so he knew if his foundation was settling in which way. So there's different ways to. There's definitely different ways to be able to.
That's also pretty ingenious. I mean, I love the way that water can do certain things in a small area, right?
But when you don't have to have line of sight to it either.
Water imagine water in the ocean sense. It doesn't equate the same way, right? But the ocean isn't level.
No.
Right?
So, I mean, this is the thing, right? But even as you're describing it, right? Water surfaces, even if they're disconnected in different vessels, they define a level, but the meaning of level is actually quite intricate. The meaning of sea level is actually quite intricate. Because it responds. Let's imagine your experiment. And I put a cap over one of your water, your water levels, and then I pump a bunch of air into that cap. Right, that's going to push the water level underneath that cap downwards, and it's going to push the water level. No, it won't create an air bubble. It'll just push the water surface down underneath it, then it'll push the other water surfaces up. Right.
Yes.
Which is to say that you are assuming that these three levels coincide with a line, collinear, and you need to demonstrate it.
Hang on, let me correct you. It's not 3, it's 1. That's actually just 2, but what you're talking about is just 1. It just
you can suck water up under a vacuum.
Yes, I could put the cap on, or I could suck water out from. I could suck air out from under it, and I could suck the water up. So the water levels
is siphoned through.
The relative. So what you're relying on here is that it is the amount of work it takes to lift water inside the pipe, and that's a matter of gravitational potential, air pressure that it's working against, and frictional effects throughout the pipe, right? And it's also got to do with temperature distribution throughout, because
that's a lot of variables. Like you're introducing so many different variables.
Complicated.
Yeah, it does get complicated, the water level.
Of course, but it could be like Tony. It could be simplified, right? It could be simplified much more than that. You can simplify water. Yes, water levels are level generally, except if they're under pressure, or except if they're under vacuum. That's generally
You could standardize the pressures.
You can fuck around with it all you want, but you wouldn't really use it like that.
Yeah.
You could artificially set air pressure. You could insert your own caps above each of the water levels and make sure that air pressure is as.
You do know how water level's used, yeah?
You can, but why would you?
Okay. Because you may have natural variations in air pressure that lead to deviations in the water level.
There's a reason why they talk about water and level in the same context. Water level. Because generally it is level. Generally.
Well, no.
Right?
We're talking about a tool, though.
Yeah. Okay. Like a level device. You're talking about, right?
So,
well, no, there's a difference. So I'll found the mystery for you. So there are different types of levels. So most commonly, there's what's considered a spirit level, and that's like the bubble level. It's like 4 foot long, and you put it on your countertop, or you want to measure and see how level your picture is going to be hanging. You use something like that. That's called a spirit level. Now, it has
a bubble in it.
Okay, so
back in the day, there's alcohol in it, and so that's why they call it spirit. And that bubble would be in between.
So Bev seems to not. So I have an observation. Bev has not said that he is not recording this conversation. So at this point, I feel like my intellectual property is being stolen by Bev.
What?
What intellectual property?
Why?
Are you recording? Are you going to undertake that you are not recording this
wanna call
conversation?
Why are you fucking?
Okay.
So
Are you
Bev,
drunk right now,
I am-
Tony?
I
Jesus.
am asking Bev a direct question.
What?
Is Bev recording this
Yeah, of
conversation?
course it's recording. Always assume you're being recorded, Tony. Yeah.
Yes.
Okay.
Always.
Well, then,
I wouldn't
then
assume,
I'm out.
that
Then I am out of here. Well done. Thank you, Bev, for invading my privacy.
What?
Oh, did that make
Did he
him
just bounce
leave?
out?
Yeah.
Did he just bounce?
Yeah. He was tired. I mean, he'd been up all night, right? He's been up a long time.
Yeah, I mean, he did start to sound a little bit drunk.
Cool. It actually sounded.
I
like
thought he was
was
drunk, but I guess he's been up for like 24 hours. Or
He
something.
goes in a shouting bit and he gets tired after it. You can hear him. It must be tiring. Doing all of that ranting and raging that he was doing.
I caught the brunt of that like twice. And plus, he called me fucking "What's up?"
Yeah.
I've only been in here twice tonight.
It's a good rest.
Yeah, maybe he has to go to Betty Buys.
Yeah,
Maybe
well,
he has
like,
to go sleep.
we came in
Well,
here
I would-
about 16 or 17 hours ago. And
Really?
yeah.
I think I was in here like 4 hours ago.
Yeah, we
So you
started
probably-
ages ago. Like we've done a massive shift. Like loads of people.
Oh wow!
Tony
Okay.
must have done 8, 9, even 10 hours, right? When did
I
Tony
went out
come
and
in?
played pool and drank with my brother, and came back on. It was still going on at Blues.
Yeah.
Like, hey,
Well, I still want to go on the subject of level, right? So level as a water level, and the whole idea of having a plumb bum, and I believe. Can I not talk about that?
no, I'm sorry. No, I'm sorry. I was interrupting. But plumb bob doesn't have anything to do with the tool of the water level.
Oh well, a plumb bum is like gravity sensitive, right? So you use a plumb bum that is gravity sensitive. And that's where you work out your
establishes
level,
a vertical, right?
Yeah.
A plumb bob's a tool for establishing a vertical.
Yeah, a plumb or a plumb bulb, right? Okay,
Yeah.
sure. And I think that's what you also get with the spirit level as well. Like it knows where, like, it's a device that can tell where gravity is focusing. You know,
Well,
like-
it does the
Spirit level,
perpendicular.
though, a spirit level, you have to actually manipulate it with your hand to try and get it to where you want it.
yeah, sometimes.
A plumb bob just hangs.
Yeah. But it's kind of like the same idea. Like you want the bubble to be
Yeah, the
in
water
the middle.
establishes a horizontal.
Yes.
That's what
Yeah.
You got a plumb bob, and then you
in-
got a water level. Yeah.
Yeah. All you're trying to do is establish like what is level to your specific gravity, right? The
Well-
gravity towards the center of the Earth.
Horizontal and
That's
vertical.
all.
You
it
mean
is.
down? Just
Yeah,
down. Isn't it?
downwards.
Yeah.
Yeah,
Well, there's no centre to down, is there? It's just down.
Well,
It's horizontal.
everywhere around the
90
Earth
degrees.
is down.
Yeah,
90
So there's no.
90
Don't have to be a centre, does there? At that point, yeah, put a centre to that.
Well, there would be a center to the Earth.
Well,
If it's
it
What
doesn't
happens?
matter
Well,
what
not really.
If
It could be
if
just
it's-
down
if-
for everyone, couldn't it?
We're not talking about
Well,
bubbles.
yeah, but it's like it's spherical, right? So we're talking about.
Well, yeah,
spherical...
but take the spherical part out and start from like a point of 0,
Yeah.
We're not
and then
model.
work from there.
Well, how
First
would a plumb
principle.
bum work?
Just points. It goes vertical.
It goes down
It goes vertical.
Right.
Yeah, perpendicular to horizontal.
to the
Level.
horizontal.
Yeah, to
Yeah.
level.
Well, 90 degrees from vertical is the horizontal.
Yeah.
Yes. Yeah.
So if you
Yeah.
work along the horizontal and you drop another perpendicular, you will have another vertical, right? And then you can walk along
but
more along
those-
that
those
horizontal. You can
But
keep doing
those
that.
two, but those two horizontals will be slightly different from each other.
Could be the same horizontal.
No, they're not.
So
That's
here we
weird.
go. Here's
Yeah.
the roundabout. Yeah.
if you got a whole bunch of spirit levels, let's say I bought a million spirit levels. I'm going to buy they're going for $1 a piece. I've got $1 million. I'm going to buy 1 million spirit levels, right? I just went out. I just
worried about spending that little
one day, right?
I'd be worried for you. I'd try and advise you not to.
Right.
Yeah, I usually buy one of probably 2 or 3 years.
Each
like,
one.
You've been watching QVC again.
Hold on.
Could you maybe shut the fuck up and let him speak?
I'm saying that I'm buying each spirit level is 1 meter long, right? So I've got 1 million meters worth of spirit level, and I'm just putting them end on end, and each one of these spirit levels are saying it's level. Oh, it's level. It's level. It's level. But if I measure where they're pointing downwards, right? Each spirit level pointing downwards, it seems to be curved. It seems like they're pointing towards a certain center of the Earth.
Have you ever used a level or a plumb bob? Have you ever used one, mate?
Yes, I have.
Right, okay.
I actually have used the plumb bob.
Wherever you've been to use one, so no matter where you go, it always is perpendicular, isn't it? Level and horizontal. So
yes. You can work out what's level to the surface of the Earth. Yes.
Yeah, wherever you are.
Yes. Yeah.
Right. So why would you think that those horizontals are anything apart than parallel to the last one? Because if I put them next door to each other, eventually they start to not be parallel. You've witnessed
they are at some point then.
Only in your own,
at the middle of the bubble?
only where you are at that time. You'd have to put one against the other.
Yeah.
How
large do you reckon the horizontal line is?
You can actually witness it with spirit levels or water levels if you have a convenient chain of mountains. You go up the first mountain and you set up your level and you look along it and see, and with a bit of measuring and some trigonometry,
you did that last
you get an angle above or below eye level to the next peak in the chain, and then you go to that
long distance optics. Is that what you're talking about now?
Yeah,
which gives you
a horizontal
above or below eye level to the first mountain, and you do it forwards to the third one, and you keep going along the mountain chain, and you add all those angles together, and you find that they don't add up to 180 degrees in each gap. There's this little bit of extra each time, which is very consistently related to the distance between peaks.
Yeah, so the mountain peaks are on a curve, you could say, right? You might say those mountain peaks are on a curve. Oh, fuck.
You might say spherical axis.
Yep. And seeing as a spirit level actually works the same way as a plumb bob, what you're measuring is an angle from overhead. So what you've just established is that the directly overhead on one peak and directly overhead on the next peak are not the same direction. So plumb bobs are not parallel.
What about if you had that spirit level and it's only level in the middle of that spirit level? Let's say it's 6 feet long, and you started at point A, and you kept it level, and you walked 1,000 miles, and you kept it level the entire time.
Yeah, you would suddenly have it overhead, right? You would have the spirit level going over the top of your head.
I'm looking at that one horizontal point the entire time.
I don't think you would. You would not be able to do that.
I mean, my legs would get tired. You're right.
Well, no. I mean that you would literally be hanging onto a rail at that time, right? And then you go, "What? Can I keep on doing it?" And then by that time,
against the water,
like a million fucking 6 meter long fucking spirit levels. You're suddenly a kilometer up in the sky, and going, "Oh fuck, what am I doing?" You have to wrap them around the fucking Earth. You can't just keep on going.
Why not? I would end up in outer space, probably.
I make it 208 kilometers up, actually. So if you try to set off and keep it pointing at something you could see from where you started, it would have to be something at least 209 kilometers tall, which is a little bit taller than any mountain I've ever seen on Earth.
Well, the good thing about water level
anywhere
is that you don't have to have line of sight.
Well, that's
if you
great
carry
thing
the
about
water level
Spirit.
with you and keep it level, you're just
the
walking along
fantastic
carrying
thing
the water
about
level.
spirit levels is that when we build something on Earth, like you use a spirit level to make sure that you're level to the ground, right? Like you want to be a level house. But like if it's a long enough house, you're gonna have to have still.
You're not level. Sorry, mate. Sorry, you're not level to the ground.
Stilts. Well,
you don't have to be level to the ground. It's the level, spirit level, isn't worried about the ground.
No. You're right. Yeah, absolutely. So, like, but what I'm saying is, like, if you built a long enough house, it might be level, like, so it's level in the middle, and then you build it long enough out level at that level position in the middle. You're gonna have stilts on each end of the house, right?
What about 150 meters? What do you reckon in 150 meters?
150 meters? If it was level in the middle to the center of the Earth? Is that what you're asking?
If there was
so it'd be 75 meters.
Point A and point B, 150 meters. What would there be, a drop in that, or a hump or something?
Was it 75 meters out from the fucking middle point of the fucking house or not? Or is it like you measure level at the start of the house and then build 150 meters out from that?
No, what I'm saying is how accurate is 150 meters if it's a horizontal line?
It's probably, I think 150 meters is probably pretty fine. It's probably still level. 150 meters, you probably wouldn't see any difference. You would see a little bit of difference in the bubble. Yes.
Could you measure it?
I make it.
I think you probably could.
There.
Yes.
So
sorry.
I make it 0. If you start level in the center and go 75 meters each way to the end, as a straight line rather than following the level, you'll be all of 0.4 millimeters off.
Yeah.
Or go level 75 meters to each end, and then go a straight line between the ends. It'll be 0.4 millimeters down.
You would see. I mean, there are some spirit levels that have that little bits of degrees of latitude. And like they'll show you how much out you are. So at the end of the house, you would see. When you put the spirit level down, you'd see like how much out you are.
Really?
I'm pretty sure you would. Yes. Like
out from horizontal.
Yes.
But
nice.
If you look up the tolerances on a big building job like that, it's usually plus or minus 5 millimeters for some things and 7 for another. Nobody works to 0.4 millimeter accuracy anyway.
Okay.
And if you look at the actual end product, it's usually not within tolerances either.
Are you serious? The datum that's set on a building site is the datum. Everyone has to abide by that. That's it. 0.
It usually has to be 0.
You can't just add a bit on or take a bit off because you feel like it.
Nobody builds a fucking building that's 75 meters fucking long.
What? Are you kidding?
Jesus.
Dude.
How big do you think a fucking swimming pool is?
Egyptians.
That'd be 50 meters.
Did Egyptians use spirit levels?
No, they used water levels.
Yeah.
When I say the tolerances, I don't mean you just start wherever the hell you like. I mean when you stack bricks and mortar up to a height of 30 meters tall, those bricks are not required to be stacked vertically to within 0.002 nanometers. They are required to be stacked to within 5 millimeters of vertical.
How tall?
Wow.
The thickness of the mortar when
someone
specified to the nanometer.
The wonderful thing about the Egyptian. Hold on, like you fucking brought up the pyramids, right? The Egyptians.
No, we're talking about bricks.
Yeah.
The Egyptians, they figured out.
Don't worry about the pyramids. We weren't there. We don't know.
They figured out something that's quite amazing. They figured out something that's quite amazing. You build something like in a square, and you build something that's smaller on top of that square, and then you build something smaller on top of that square, and you go smaller and smaller and smaller until you got a fucking square pyramid, motherfucker. Like, it's most stable structures.
Yeah, we know that.
It's called stability.
Yeah, they start with a level base that they probably use the water level, the tool, to establish that 0. Not 0.4, not 0 minus 0.4.
How many pyramids do you know that have fallen over?
Spot on, you moron. Pay attention to what's actually being said, not what you wish someone had said.
Dude.
Tolerance is how close to the straight line the object has to finish up.
Just a minute ago, you said that you do a stack of bricks, and if it's at this height, then it's not as accurate as this height. Well, if someone says, "Can you build that wall?" to me, as I do that as a job, they say, "I want that 4 meters high." I make it 4 meters high. Like, what do you want about tolerances? There's no tolerance in that.
Let's say that stack of bricks is 100 meters high.
Then you do it 100 meters high.
Yeah.
Is it going to be? Is it going to be stable?
Are you serious? Of course, you're going to be 100 meters high at 100 meters.
Oh, do you think the customer might accept 99.9999995 or 100.000000049?
Well, that's up to them. But as long as I do my job right and take it to 100 meters, then that's
you're going to be able to make a stack of bricks 100 meters tall.
Well, do you know about bricklaying? You wouldn't stack bricks on top of each other.
There are no things that are built like that.
What do you mean built like that? What, 100 meters high?
There are things. List to me the amount of things that don't have stability at their base without just stacking things on top of each other.
What's stability got to do with a measurement?
Just
why do you keep talking about shit like that?
Like a Jenga.
If you want to get to 100 meters high from 0, then you'd establish a way to do that, wouldn't you? You'd either build it on a triangular basis, or you could, build a ball that was 100 meters square.
Yeah, but if you're just stacking things on top of each other, they're not going to last.
Like
but the pyramids have.
Like those chimneys.
Oh,
pretty solid.
Yeah, but they're not dry, right? Chimneys aren't fucking built just dry.
Who said anything about dry? What the fuck are you talking about?
That's what I'm talking about, stacking things on top of each other.
Well, we're not. You're just injecting something that's in your own imagination into a conversation that we're having about something else. Please don't do that.
We're literally talking about a measurement and how accurate you can. That's what I was getting at, what you're talking about, but you seem to be like, anyway. So, let's get back on track. Or not.
I'm making a brew. Can't remember what we were talking about. I think it was Sugar talking to Thingy, but PhD Tony left. Somebody else wanted to take over.
Yeah, I don't know. I have a feeling he might be listening in.
Yeah. Well, I think he'll be going to sleep.
We're not interested in how to build things. We obviously we are, because we're. Yeah, I take that back. I mean, well into learning about how the pyramids were constructed. That doesn't everyone.
But for the building side, guys.
We're talking about a level.
Yeah, for building, Spot On is the expert, right? So don't assume that you know more about stacking bricks than the guy that does it for a profession. It's his job. He knows more about it than anyone.
Yeah, thanks.
Definitely uses a plumb bob more than anyone. I bet he uses the plumb bob more than all of us putting together. And the level, obviously, but he's always got a plumb bob or a level in his hand. Well, not always. I'm obsessed. But yeah, he's our expert for building. But we don't talk about building, right? It never comes into it. Other people want to take this conversation into areas that we're not talking about. We're just talking about the water level. How we can relate Euclidean geometry to it to help us show the practical principles of geometry in reality. Sorry if it's upsetting for people.
So who else wants to talk about stacking bricks? Conversation exhausted.
Yeah. See, it's a practical thing, and unless you've actually done it practically, you can imagine it is whatever you want to imagine. It doesn't make it real. The only way you can do this is practically do it. First off, you're best off just trying to get the principles of the idea, the understanding of what it is.
Someone called me a moron earlier as well, I think.
Yeah. PhD Tony.
Oh, I can't remember now. It was someone. Someone chimed in. It's not a good day unless you get called moron. Normally means asking questions when I get called moron. That's what the relationship is.
Yeah, the wrong question, right? You asked the wrong person the wrong question. That's what I found anyway. And a lot chatty in the live chat, you know, in the text. Not many people want to actually come and talk.
I'll be back in a bit once it's quiet.
Yep. It's quiet. What did you when I woke up this morning? What's up? What was it that you did to Tony? What was it you were talking about? Well, you get a bit more technical than we ever normally do. So what did that conversation go into?
Oh, you're asking me?
Yeah.
About Tony?
Yeah. What was...
Tony had a problem.
Yeah, go on.
With me asking him the first time what is he getting distance from when he only has time, and he was right about the first part, but the second part he wasn't, and that's when he got mental. I was asking him, how do you get distance if you do not have a constant radio signal speed? And that's what happens when we are talking about, satellite signals coming from outer space towards the ground. Not constant speed. That's when he went mental, because he knows that there is no answer to that.
He did say, didn't he, that it's changing, different.
Yeah, and he went into error correction, which he didn't describe whatsoever.
Yeah, just to correct it, because the difference, right, that it should be a constant. So I thought that the error corrections were to correct for the constant that it wasn't, right, to make it into that constant. I think that's what he was trying to say, in my understanding. But
well, that's what I wanted to ask him. How does he correct it? Like again, if you do not have a speed, or if you do not have a constant speed, or if you know that the speed that you are trying to look for and determine the distance, because that's what it's about, right? GPS. If you know that the speed is not gonna be constant, then what do you do?
Okay, well,
so
let's say you
Nothing.
have a constant of 33 miles an hour, and the results comes back 32, right? So your error correction would be 1. I'll just plus 1,
depends on the
and then it
speed at
gets
which
to
the emitter
33.
is traveling.
Go boom, error correction
You
done,
are
sorted.
talking two at the same time. Doug had a question, I think.
All right. Well, I was just explaining that.
Are you saying that the speed at which an EM wave arrives depends on the speed at which the transmitter is traveling?
When did I even say transmitter ever? Like literally. No, I was talking about radio signal coming from the GPS satellite and going through the atmosphere.
And having a speed.
And having a speed change because it goes through the atmosphere.
Yeah. And
that
change needs to be adjusted to make it back into the constant.
The way you said it the first time, I thought you meant because it was coming from a moving satellite. And I thought, no, that's not right. But yes, it does slow down because it's going through the atmosphere.
Okay. So
by how much?
Constant.
By how much does it slow down? How do you even know? How do you account for it? How do you get the real speed? And what do you do with the different speeds? Because it's constantly changing, you know.
Yeah.
How do you get that? And from that, how do you get the distance? You don't. Actually, you don't. That's the real answer. That's why Tony got really fucking mad, because you cannot have a distance with that method. With another method, you might could. I'm not sure about that, because I do not know any kind of other method. But he didn't describe that. And then he was, shouting over me for 10 minutes straight. And then he said that he will, whenever I will talk again.
Yeah.
So,
yeah, it's a tricky question that once you get
to actually establish what the current speed of light through the air around you is, I think you would need a vacuum chamber, and you could shine a light through it at an angle. If it had very well polished parallel glass walls, the light would get refracted going into the glass and then coming back out of glass into vacuum, and then going back in from vacuum into glass, and from glass back into air. And
yeah, you're kind of right about that, but we are talking about a signal coming from outer space through the atmosphere of the
Earth. That would change the amount it deviates on the way through the box, and you might be able to measure that deviation at the far side to get an optical density of the air. Might work. However, optical density of the air is pretty close to 1, as in pretty close to the same as vacuum. So you're going to get some inaccuracy from atmospheric conditions, and GPS systems are inaccurate, especially at low altitudes, and you do have to leave the thing running for quite a long time to get a really good fix.
GPS is inaccurate in low altitudes, because I heard the otherwise, by the way, and I experienced it 100,000 times.
It's designed to work at low altitudes, so the system probably has all kinds of calibration issues if you go above where it was designed to work, but the lower altitude you get to, the more the atmosphere is going to interfere. But
I'm sorry, if I'm closer to the satellite, because I am at a higher elevation, it should be more precise, shouldn't it?
I don't think you're that much closer, really. The elevations at which we work aren't a very big fraction of the altitude of those satellites.
Okay.
I mean, if we're talking about geosynchronous satellites and geostationary satellites at 30-some thousand kilometers up, and aircraft operating up to 10 kilometers up, that's a pretty small percentage of the altitude of the way to the satellite, for a huge loss of air density and a huge increase in difficulty breathing.
I was talking about radio signals. I do not have any idea about why you're talking.
Hey, what's up? Go to the doctor.
Okay. Yeah, sure.
Yeah, if I was hiking around the Lake District using a GPS, I would not count on it to tell me where to go. It's it's kind of nice to get a confirmation of where you are. It's great somewhere like you're walking around Casablanca and you want to know which way to go back to the hotel. If you already have the map on your phone, you look down, the GPS says you are approximately somewhere kind of at the south side of this big roundabout, and you look about and go, oh, that big roundabout, right, I'm at the south side of that, and you can follow the map from there back. I would not count on one to tell me where to turn left to go down Swirl Edge off Helvellyn, for example. No way. Because that single GPS unit where you're just holding the thing in your hand and it's saying you are currently at this location. Where if you really want to be accurate, there is another trick you can do, which is differential GPS, where you have two GPS units and you know exactly where one of them is by some other method. You've properly surveyed its location, or you don't actually care exactly where you are. You just want to know where you are relative to that point. I don't know, for some construction out in the middle of the desert or something.
On from the
and
speed
because
of the
conditions around you and around your static station are very similar, unless you're having really bad weather, you can make the assumption that the atmospheric interference with the signals reaching you and with the signals reaching the fixed station is going to be very similar. And then they cancel out and you find yourself with your distance from your fixed station being pretty accurately worked out. Even if you don't know exactly where either of the stations is, you know how far apart they are and in what direction.
I'm sorry, what cancels that? What?
Well, say you're having atmospheric interference and it's causing all your GPS results in this entire 5,000 acre patch of desert to actually be incorrect and to give you a position that is 60 meters east and 15 meters north of where you really are. And wherever you go, you're going to get somewhere like 59 to 61, well, 59.5 to 61.49 or something, 60.9 meters east of where you really are, and 14.99 to 15.004 meters north of where you really are on your GPS readout. But you have a GPS unit sitting at on top of a boulder whose coordinates are exactly known in the middle of this patch that you're surveying. And then you carry a GPS unit in your hand and you get two results. One from the one sitting on top of the boulder, one from the unit in your hand. Both of those results are wrong by the same 60 meters east and 15 meters north because of the atmospheric conditions or whatever else affects them. But the difference between the readings you get is correct to within some much tighter tolerance.
But you get the same readings, don't you?
Sorry?
But you get the same readings then, don't you? So what difference in the readings? You get the same.
Well, no, you've left one of your GPS units on this boulder, and you have walked 200 paces north and 500 paces west, and then you look at the thing in your hand, and it will give you a position that is 181 meters north and 462.3 meters west of the position that is being reported by the GPS unit you left on top of the boulder. And those numbers will be how far north and west of that boulder you are, even though both of them are telling you you're actually over the far side of the main road somewhere.
What I'm getting at is that in the first place, you shouldn't have accurate data regarding where you are because of the interference. But we do. Like we really do.
Well, if you leave the GPS unit sitting on that rock for a week, the weather's going to change quite a lot, and all the errors are going to wander around all over the place around that rock. And given enough readings, you can, from enough different satellites and enough different weather conditions at enough different times, you get a cloud that pretty well focuses on that rock.
Wow. Is that where you get your error corrections from then? That data set.
Circling around a rock. No, that's not it.
Moving rocks.
No,
yeah, you have to stabilise moving rocks, don't you? That's what would be done with error corrections.
I got fuck all idea what he is trying to say, because in the first place I was trying to say that you are actually accurate. And regarding the model that you are presenting when you say, or anybody says, I'm not talking about you per se, but when anybody says that there is a satellite out there and the signal is coming through all this atmosphere, you know, and having interfered back and forth, right, all the fucking time, it shouldn't be accurate, but it is.
Go to the doctor. What's up?
Oh, here we go. Is that Billy?
Yep, that's it. Okay, then we can move on. So, it shouldn't be accurate, but it is.
I don't know where you live, what's up, but at high latitudes like where I am, well, actually anywhere on Earth, shortly after sunset and shortly before sunrise, and at high latitudes all night near midsummer, you can go somewhere dark outside and look up and watch satellites going past. And they don't twinkle.
That's another problem.
They don't twinkle.
Just purely talking about the
If
signal.
you're looking over a factory or through the smoke from a chimney stack or something like that, or across a motorway with a lot of heat, or over a city, yeah, you'll see stars low to the horizon twinkling because there's a lot of turbulence in the way. If it's a really foggy day, you won't be able to see that satellite gleaming. But if it's a clear night and you're out there and looking up at a clear sky and not looking through all that turbulence or heat haze or pollution, you get a very steady view of stars. And of low Earth orbiter satellites gleaming in the sun coming across the poles.
Great, I was talking about the radio signal coming supposedly from the satellite.
Yeah, radio signals and visible light are electromagnetic waves.
Yeah, okay, but that's not what I'm talking about again. I'm not talking about stars and light. I'm talking about radio signals getting interference.
Radio signals are electromagnetic waves. Visible light is an electromagnetic wave. Invisible infrared light is an electromagnetic wave. Ultraviolet light is an electromagnetic wave. Radio waves are just very long wave light.
Cool. No problem there. You are not arguing with me. You are just talking about something very different, that's all.
The fact that light coming from that satellite can reach you without much interference or disturbance or, scattering or twinkling effects through the atmosphere kind of strongly implies that light coming from that satellite can reach you without much disturbance or distortion or twinkling effects coming through the atmosphere.
Yeah, I get a good rebuttal to that, but they are telling me that my microphone is very bad. I'm gonna reconnect one moment.
Yeah, that's really bad.
Oh, fuck.
Really, Colon? Are you in here?
Okay, is it good now?
Yeah, that sounds sweet, that.
Okay. So, Doug, when you were talking about seeing lights in the sky, how do we determine if what we see is actually there where we see it? Because if all we see is lights, we just cannot know where the actual object, the physical object, is. If that light gets reflected within the atmosphere,
If it's physical.
Yeah, by the way. But, how do you determine what you see on the sky is actually where you see it? It's like, imagining shining some light on your window, for example, from the side. And you cannot see where the light is actually coming from. All you see is the circular light that is on your window. Refraction.
Well, a good first step will be to make a very detailed map of all light you can see from one particular location, at what time, on what night, over the course of a year. and then compare it to a similar map for other locations. And if everybody's seeing the same patterns of lights, just slightly shifted, then they're probably all seeing the same lights.
Well, my example, again, you are in your room, in your house, and someone is lighting a flashlight on your window from the side from outside. And you cannot see the person because he's actually behind the wall, and you are not looking at it at such an angle that you would see the person shining the light on your window. From the inside, everybody could have a different angle towards that light that is on the window. How would that ever determine where the light is actually coming from?
It would give you a really good idea of where the window is, though, wouldn't it?
The window is where the window is. We can see that. We can measure the distance to the window. That's okay. But if we cannot see the physical object actually emitting the light in the first place, all we see is the refraction, then we cannot determine where the initial emission is coming from.
You want the cheeky answer? Try cleaning the window.
We would actually have to go out, by the way, that's the answer. We would have to go out of our house and try to search for the source of the light. But we cannot do that if we actually only have the experiences and the observation of the light on the sky. And nothing else, because I cannot go out there, you cannot go out there.
We can make that map in very great detail and notice that actually the pattern shifts very slightly over the course of a year, with them all drawing little circles.
What pattern shifts? I don't get that part.
The pretty pattern of lights you get if you take a photograph of the sky on a clear night.
Oh, and I take it every night for a year, then I would have like a line I could, make up by superimposing the images, right?
If you choose a particular pair of stars to line up, you will see that all the other ones are going in little circles relative to those. Not around them, just tiny little circles in place. And if you measure the size of those circles, you can pick out the most distant, the one that does the smallest circles, and the one that does the largest based on any particular location, and eventually come up with a hierarchy of circle size, which gives you this parallax thing.
Yeah, I get what you mean, but the parallax is not about the circle size at all. It's just an apparent of something that is something is in front of something else, and your perspective allows you to see that depth a little bit because of the phenomena called parallax. But that has nothing to do with the actual size of any kind of circle that you could draw up from the movement of the stars. That has nothing to do with it.
Oh my god.
Drawing that circle over the course of a year is exactly how they establish the parallax.
Yeah, the parallax is a phenomenon, but how do you get a distance from just the parallax?
Well, you need to know the size of the circle you're doing. It's like walking back and forth across a bridge looking at the lights of a town. If you very carefully map where they all are, you can figure out which street lights are how far away as a multiple of the length of the bridge. You do need to know how long the bridge is to work out exactly how far away the street lights really are.
What? Are we measuring the distance of the bridge on which there are the lights?
No, you're looking at very, very distant lights.
You just said you have to know the length of the bridge.
You're looking at a bunch of distant lights on various hillsides all around while you walk in circles round around a football pitch. There you go, there's something circular. And as you move around, the patterns of those distant lights, like people's porch lights twinkling over there on the hillsides, will very slightly change. You're looking, I don't know, along a couple of valleys, and you can see lights of farmhouses up on the hillsides on both sides of both valleys. the view up the valley will be very slightly different from each position on your course around this football field. You can use that change in the view up the valley to figure out how many football fields away from you each of those farmhouse lights is.
Yeah, but that's what I'm asking you in the first place. How do you actually do that? Because you are bringing up the third example, but not explaining either of them explicitly in the first place. And the second problem is that I'm trying to say is that when you are trying to, what do? You measure the circles, right? Now, how many problems you can have just by measuring the circles? Like, is that a precise thing when you do that? Measuring circles on an image? That you actually, in the first place, superimposed images upon each other. Now that's already fucked up, because we do know that's not precise whatsoever, superimposing different pictures on each other. That's not precise. And then you are measuring a circle, diameter or a radius or whatever you want to, actually measure that circle. Like that's not even close to be precise whatsoever. Each time you do that,
it can't be done. That's good enough for me.
Each time you do that, you will get very different distances to the stars that you are trying to calculate for, because of the errors that are getting in when you are doing the superimposing and then the measuring of the circle.
Yeah, but we get very different distances that are like anywhere from 420 to 440 light years. Not anywhere from 400 meters to 420 light years.
Yeah, I gave you a small door out of this conversation by actually asking you two different things. You answered to the second one right now, but the first one was, how do you do that in the first place? The parallax calculation. So far we have circles by superimposing pictures upon each other.
You don't have to superimpose the pictures. You can make the measurement on each picture separately and have a list of measurements.
One picture of one star or one sky won't give you a circle, right? And you are trying to say that you are having a measurements regarding circles, so the path of the star that is making throughout a year, that's superimposing in the first place.
Or you could measure each one and just have a list of measurements.
Okay. Measure what? A dot? What do you measure?
The angle and direction between the visible lights.
Oh, so now it's not about circles, but just dots, and you are having what kind of angle towards each other? What is your base? When you have two dots, you have like one straight line. Where is the second one for having an angle? It's coming from you setting up the camera horizontal, like totally horizontal, or what?
No, it isn't. There's nothing about being totally horizontal here. You're pointing a camera at a whole bunch of stars through a telescope. You're taking a photograph with a known field of view.
Okay, by totally horizontal, I meant you set up the camera as being totally horizontal, and then you pan it upwards, so you don't tilt it in any way. That's what I meant, but okay.
That's completely unnecessary.
What you wanna have? Then what? Again, what is your second straight line? Because one we can have, of course. Anytime we have two stars making one straight line. What angle are you referring to when you say you measure angles?
From one star to the telescope to the other star.
To the what? To the scope? So to the camera, right?
Yeah. Star,
Like
camera, other star.
sextant
That angle.
or something like that. Uh-huh. And then what you do, because again, I was asking about parallax calculation. Yeah. I tell you what, I'm gonna tell you that I got fuck all idea how they do it, how they do this when they are trying to do it. But you know, you said that you do know. If you do, please explain it to me.
It just was explained to you.
What, having angles in between two stars give you a distance to the star? Okay. Because that's what we heard so far, but...
Is your goal just like not to understand geometry or what?
How does an angle in between stars give you a distance from where you are towards the star?
That was just explained to you.
No, he hasn't. He only said about angles in between stars. Determining an angle in between you and the star. That's an angle, not a distance. I think you are mixing up some words.
You sound a little bit different there, Billy.
You mean unusual, or?
Yeah.
Well, Cambridge University can probably explain it better than I can, so I have put 4 links from Cambridge University into the live chat. Have fun
They're
there.
not going to understand that, dog.
Thank you for that, by the way.
See, he's trying to
That's
do a
at least
Louis
something.
voice. I remember when Louis came round. You've had voice training, Billy. You don't half sound different.
Okay, one of the, I think is the first one. People.ast.cam.ac.uk is literally just 3 sentences, 1 image, and the first sentence starts with the following. Hear this is good. Hold out a pencil at arm's length so that it covers your view of a more distant object. That's how they measure things. Holding out a pencil.
Well, in addition to that,
God.
you're not just supposed to just dump links and then say, have at it, you motherfuckers. This proves my point. That doesn't make any sense either. Not to mention when you do look at it, 1 or 2 sentences. This is stupid.
He's been
Well, I give him the, that's not a problem for me. Like, he can. It's certainly fine. He didn't still explain anything regarding it. That's true also, but, at least he's trying to show something for what he's claiming.
No,
well,
he's
the
just
first one was this.
He's just dumping references and say, you go find it. That's not.
Yeah, and I
proving his
found
point.
that we should actually measure distance to the star by arm's length having a pencil at your view. That's how the big boys do it at Cambridge University. Great.
Okay, so maybe that one was meant for kids. There's a different one. Try Gaia. See whether that video helps.
Are you just Googling stuff and finding what comes up without actually knowing anything?
It seems like it, by the
Yeah.
way. Yeah.
I mean, wait for him to
just
read it.
explained it.
It's like you've got a great voice. I think you should do audiobooks, actually. So if you want to read it, I'll listen, but it doesn't mean you know anything.
He just explained it to you.
Thing is, it's a lot easier to post links to their videos and diagrams than it is to draw them all myself.
That's the thing. You wouldn't be able to draw them yourself because you don't know anything about it. You're just Googling shit and posting links, dude.
You're just trolling. Could you explain in 5 minutes exactly how a high bypass turbofan engine works without any diagrams?
If I knew what I was
Clearly,
talking
to someone who knows nothing about it.
If I knew what, so you're saying you don't know anything about it, you're just posting fucking links. That's what I'm saying. No, it doesn't work like that. Shouldn't be doing that. Silly.
You don't even English.
What?
Maybe he's confusing you again with me, by the way. That's the second person today. Oh my.
What's English got to do with it?
They're saying, I don't know.
What Sugar Cookie just said didn't actually make any sense at all.
You posting links is not a way to prove your point. Did you understand that?
You running your mouth is not a way to improve a conversation.
Okay. I expected nothing less from you, dog.
We'll let you know if we need to know anything about turbofan engines, though. Should make sure of that. Sounds like you're an expert on that.
Can't take someone seriously that names themselves dog.
Well, if I didn't know anything
from that page, I already have a problem with it, that it's assuming stars are along the axis of the Earth's orbit. Of course, if a star is lined up with the major axis of the Earth's orbit, then you won't see the major axis of the Earth's orbit as the major axis of the ellipse described.
Is this you reading another page or two?
No, fuckwit. This is me explaining that I have a problem with the page that I just linked.
So that's what you're reading?
No, fuckwit. This is me explaining a problem that I have with it. Fuckwit.
Okay.
Sugar Cookie, are you retarded or something?
Ad homs are great.
Yeah, drop all the
Keep 'em
swearing. Doesn't make you big and hard.
Keep them coming.
Like, you know for a fact you wouldn't say that to him in person, would you?
I would absolutely say that to him in person.
I wasn't talking to you, I was talking to dog.
Of course you would,
You
because
don't
you
know
have
me in person. Spot.
Yeah.
I'm keeping out of it. Fuck it.
So as I was saying before fuckwit there tried to talk over me again, the Gaia website describes the method, the parallax method, assuming
Some more
that the star
add-ons, is that what it is?
along the axis of the Earth's orbit around the Sun.
No problem, yeah.
Which works fine if it is, but they say that the major axis of the observed ellipse will be the same size as the major axis of the Earth's orbit. And I think that if the star is in line with the major axis of the Earth's orbit, the major axis of the observed ellipse will actually be the minor axis of the Earth's orbit. So you'll get an inaccuracy introduced that way.
Well, that was some word salad.
You not understanding it, Spot, doesn't mean it ain't true. Just like you not understanding that building projects are done with tolerances doesn't mean building projects don't have tolerances.
You reading from
I'm saying there's no such thing as tolerances, but if someone says to measure to build something to a certain height, you do that.
To within tolerances.
Yeah. Okay, yeah. Is it like the 0 point that they give you? Anyway, go on.
Like so sloppily that 0.4 millimeters wouldn't show up.
Still not the measurement though, is it? I missed all the chat earlier about the water level. Sorry, I had to have some family around.
Yeah, it keeps getting diverted off it into other.
Did you get you got it recorded? Yeah. I wouldn't mind having a listen to the bit that I missed. What did Dog think of it? Dog, did you have an opinion on it?
Opinion on what?
Water level and the water level test. Did you actually get to? So, well, you may not even got round to actually explaining it, Bev. So that's what normally happens.
They all have their own idea what level is, so like PhD Tony, I think he's straight lines curve. They have to. I was trying to explain to him last night, the horizontal's gone. That's the new skill.
Well, they're using horizontal as a straight line earlier.
The old schoolers do, until I realise that a horizontal is established by a tool called a level. Then it has to get smaller and smaller to the point that it doesn't exist anymore.
Yeah, it can't be anything but that point. Strange.
You guys go around the clock, or you slept a bit?
I had a bit of a kip.
What a day yesterday,
Yeah,
huh?
I see. I was up early, and I saw Buster in there, so I joined Buster, and it carried on from there. And then everyone else has rejoined since, so it was like continuous. It hasn't stopped.
I saw Buster in here too.
Nice.
Blues 24/7. It's kicking.
Blue is swinging. Wow.
Oh shit! It was Buster that was that I came back into it, and he was going on with Cyman Dan. I mean PhD Tony.
Oh, that's an insult.
Just for reference, SC, PhD Tony kept getting me and What's Up mixed up, and he went off on What's Up, and then I having a conversation with him. PhD Tony flipped his shit like 5 times, and he, in the middle of his tirade, thought I was What's Up. I'm like, dude, this isn't What's Up. He goes, what?
He calmed down instantly, didn't he?
He seems pretty uptight, man. Yeah.
I didn't catch that bit. I thought I didn't hear the end. Is that what happened?
Yeah.
Oh, I don't know.
It was a bit. Yeah. It was all over the place, but yeah, it was. It's impressive.
I was telling him about water levels, and then he gave me a reference to how the Earth is spinning and sea levels on the western coasts of something. I've got it in my Google history or whatever, but I was like, that's a non sequitur. It's not what we're talking about. And then he just flipped his shit.
Yeah. Yeah, he started calling him "What's up" again.
Yep.
It's like that was the biggest insult he could call you.
If the water level test you're talking about is putting a 2-point water level and another 2-point water level end to end and a 3-point water level beside them and hoping to see no difference between the water levels in the center of the 3-point and the ends of the 2 points that are together in the middle, and to then claim that as proof that there's no curvature, then
hold on.
No.
address that one.
Wouldn't it be nice to take this young lad? Wouldn't it be nice to take this young lad on the whiteboard?
Oh no!
I'm sure that's an accurate representation.
I'll show you the model.
If that is the so-called test that's in question, it is fundamentally very flawed.
It doesn't
because
sound
your
like
description of it, I don't think your description of it is what it actually was.
Yeah.
That's actually flawed. The actual description, yeah. Everyone that drew it earlier on that I saw was doing it on the curve.
So yeah, you're right. It is flawed, but that's based on your wacky description of it.
See that? It's
exactly
that.
Pretty much
just
by
scaled
design
up
and
with
by
those
definition
numbers.
show
Hey, dog, have a look in that, mate. There you go.
Hang on,
planes. So if you get a whole load of near vertical pipes connected bottom to bottom in whatever grid pattern or wiggly line you want, and fill that apparatus with water, technically you should enclose the tops together as well, because otherwise you get wind speed across them, but let's not worry about that. Wow. The water will fill those things to the same level, not to the same plane.
You haven't stopped to actually listen to an accurate description of what it is yet.
That means if you start at one end of that with the northernmost point and draw a straight line from there to the southernmost water level, you are not going to go through the water levels on the intermediate pipes. You're going to go below them.
Your perception of what it is isn't what it actually is. And I think Bev was going to describe it.
We know how water flows.
I was going to describe something. I thought he just did the garlic bread sketch over and over again.
Again,
you know how water flows? We know how water flows. Do you?
SE Montreal, you don't know anything.
Who was that?
That's Billy. It sounds different.
That's Billy Boy.
Wow,
it didn't sound like that when he came round.
Sounded younger, yeah. You catching a cold or something, Billy?
I don't know, maybe.
Hope it's not that dreadful. Shall we not name it here? Because we like blue.
Take your vitamin C. So, I mean, dog. If you're wanting to listen to somebody accurately describe the test that had been done, then just say so.
Can you accurately describe it?
There you go. I'm showing them in that picture.
Yeah, I did. I did earlier. I don't know if you were listening. I think somebody else
doing something more important.
Probably.
Can you use that tall dude in the picture to do parallax?
2-point water levels?
Sorry, were you talking to me?
Well, you said you'd accurately described it. Go on, what do you have? Long line of 2-point water levels, end to end, or?
Well, I described it earlier. I don't want to describe it again. I think somebody else probably
Just tell him it's 2 4-point water levels. He's got me muted.
Or if this is supposed to be that part of that force the line thing, you know, the maths have been done for how precisely you'd have to build your straight structure, and it's way beyond capabilities.
And you're not listening.
Well, you're not talking.
He's got me muted.
No, I'm not. That is.
Yeah, he's got me muted.
You don't expect me to actually care, do you?
There you go.
Can you hear Bev, or do you have him muted or something?
Well, every time I try to answer any of his so-called questions, he talks over me with ludicrous incredulity. Carry a water level. Carry a water level. Am I hearing you right? Carry a water level. Carry a water level. I don't believe I'm hearing this. Did you really say carry a water level? And then, when I finally get to the end of it, despite all his attempts to interrupt, he just says that he didn't listen to a word I said. So if he's not going to listen to anything I say, why should I listen to anything he says?
Well, because he's describing to you the water level. Can you unmute him so he can tell you about it? The test?
Well, I could do, but I don't see the point.
Yeah, it's not worth
Okay,
it.
so you don't want to
worry
know.
about it.
Yeah.
Well, it's Bev. It's not going to be a valid test anyway, is it?
Why? Why's that?
Yeah, why is that?
Retarded.
Come on, ask him, please. He might have you muted as well. Spot on.
Why is that?
Why is it not a valid test? Because I've performed it.
Maybe you could provide it as a nice, tidy diagram. Crisp and clean without using lots of different colours of silly fonts. Just nice, neat diagram.
How about a fucking model of it, scaled down?
Can you see the picture in the, the live chat thing? It's a replication of the test. Nothing needed to be said, unless you can't see it clearly, and then obviously.
Or if he's got you muted too. Some people mute the voices they don't like to hear.
Dog. Do you have...
Is that like putting your fingers in your ears?
Yeah, I think so.
Do you like dogs?
Is dog muting everybody so he doesn't have to understand the test?
Yeah, I think so.
Okay. He can just make up bullshit about it if he wants. I guess.
Nobody ever told
You
me
guys are
anything
too
about
retarded
it.
to understand your own tests. It's like pointless.
So
do you know what it is?
Overlapping water levels then, rather than end to end with one overlapping both of them.
Oh
it's
my
not
God.
fundamentally different.
Shared straight line segment, right? I don't think anything else has ever been claimed, but he wouldn't know because he can't hear.
I mean, apart from spending half an hour trying to conflate level and horizontal again, because Bev spends about 25% of his life trying to conflate level and horizontal. If you have a water level, it is mapping out level for you.
He's got me muted and he's
horizontal.
talking about me. It's cool.
Yeah,
Do you have
points on the water level
Bev muted?
to get a horizontal line that is horizontal
Stop
at
talking.
the
Do you have
midpoint
Bev
between
muted?
them. You can use a 4-point water
He's
level.
muted you as well. We can't hear
In a
you.
rectangle.
It's gonna be the same way with you if you keep it up.
Of the apparatus.
He can't hear
Use a
you.
long line.
He's muted you, Essie.
Just not gonna work.
Level, just extending into the distance.
Oh, he's probably muted me.
Yeah.
Yeah.
They won't. They'll be level.
Muting SE Montreal is a great
same
idea. That
thing.
dude's fucking crazy.
Right.
Well, that's the only thing
Does
you
that
guys
mean
have,
we're done,
because-
right?
Yeah, I guess we're done here.
We've got
yeah.
other places to go to. Other people to see.
Go to the doctor, dude. For real.
Tell Dog, thanks for having us. It's been a nice time. We might come back later at some other time.
See you, Dog. We're out of here because you muted us. It's been nice. We'll see you another time.
Yeah, Bev says thanks.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.
Some of the other days we've come down and it's been quite clear. We can see from here all the way to the sluice gate.
Shit.
So
from up here though, you can't come any lower.
No, from literally from this point, from right here. So.
And that's with cameras, not
we've used a viewing scope. He's got an auto level. We haven't actually done that. But when we were doing things before, when we've had only a few of us doing things. We've set things up. We set things up the first time. Went off to do things. Came back. Someone had stolen it. What? So don't leave anything unattended. We had some batteries we were using to charge electrical equipment and stuff like that. And literally we went down to the first post. Came back. I mean, stupid on our part.
Yeah, totally. You wouldn't expect it.
But you kind of don't expect it.
That's the position that you can take.
Yeah, we've been using this one is the one we can definitely see.
I've got some nice rocks in the back. Look at them.
I've got a couple of nice dogs there too. Look at them. So serious picture.
There was a guy, 1870s, stood in that canal there, 8 inches off the water with a telescope, and he said there was a guy on a boat that went away 6 miles down there, and he said he could see him.
Hopefully not with a naked eye.
No, well, with a telescope.
Wow, impressive. So you guys all from the same uni, or?
Yeah, which is brilliant. That's me. Now we're all together. Yes,
So they're doing an optics test.
So from this point, you can actually see all the way down to the sluice gate 8 kilometres away.
Okay.
I don't think you can today because it's not particularly clear, but I've been down here a couple of times and we've done sort of viewing measurements. So there's 2 groups of us. This group are global skeptics. We're here, me and my other group who aren't here. Yeah, we're here to basically show you can confirm the curve that we have.
Interesting.
So it's going to be an interesting thing. It's different groups, different opinions.
Shame the water's not a bit higher and a bit cleaner.
Yeah, it's going to be interesting. I mean, these guys have got better equipment than we have, so it's definitely. I'm looking forward to seeing if I can see through some of these cameras and things. It's quite exciting. But yeah.
How about 11:30?
Awesome. It's a good pub. I will recommend the pub. Mark is always late.
So we can see right to the sluice gate zone?
Yes, from here.
From here, yeah.
Yeah.
So,
I don't know if I've got the pictures. My phone may be really small, so it'll be hard to see. Where's that? So these are some of the things we've been when we were doing our tests. So there's do you see that white stone? That's one of our steps.
You put one of the poles up?
Yeah, so there's poles with like a big white and black target.
How far down is that?
That one is the...
Well, how often are they then? There's one
they're,
there,
they're every,
that one up,
no,
okay, sorry.
They're every 2 kilometres.
Shit.
And the one at the far end is 30 feet high.
Why didn't you I thought you were going to like measure off the water and put the target in respect to the water.
So yes, they are. So we know how high above the water the targets are. The targets can be adjusted.
Well, you got like on rope or pull them up or something.
Basically flag bomb. So and basically the idea is to get them to appear level, all on the same line on there.
From here, looking there.
So looking from here, along there, they'll all appear at the central point of the viewing. It's got a camera like that. Viewing point, and then obviously.
We're going to measure down to the water from now on.
That sort of thing.
Everyone can say the water can be ground, but no one said the ground's beside it.
No, because we're so we know how high the poles are above the water, so we can take that.
online talking about it.
So I find it. I have.
Are you one of the ones that post flat earth? Not that I'm a flat earther, but
so my interest is so I'm fascinated with creationists and people who believe various other strange things. So, for example, down globes, and so I find. My interest is I accept the possibility I could personally.
Mind you, if you're wrong,
exactly. Yeah. Personally, I don't think I'm wrong, but I want to know why people like yourselves.
Well, I mean, like the doubt comes in when you've got something practical like yours. And then you've probably been through the whole sort of test. Geometry relationship, straight line seconds. But I think you're right. It's interesting. It's going to certainly document what optics do.
I have said to I've said to him several times that it's going to be an interesting experiment. I don't expect it to convince anybody either way.
We're here for our own.
It's going to be really interesting. We're
as individuals, it's hard to get the answers to our questions, aren't we? That's what we're
I mean, I have a lot of respect for that. I have a lot of respect for people who are, who go out and actually test things. It's because I'm part of the local Cambridge Skeptics. We got sort of first involved in this sort of topic. I've been interested in the flat Earth discussion for about. I remember when the Flat Earth Society forums first appeared online, and I used to debate with people, and that's probably about 30 to 50 years ago. Either the height of the sun or whether the Earth globe. And I thought this was fun, but for me personally, I found that when they showed the results, I found it really quite profound. I was like, okay, this is the result. If you map the data out of the flat surface, you get this result, which could be easily explained by saying, okay, it's like a rainbow. Somebody was really basically took the flat Earth data, so the flat level data with the data, and then curve it down in some manual up and down into a ball. And when we turn it into a ball, all the measurements point in the exact same direction. And for me, I found that I was like, okay, let's say that the Earth is actually flat. You've got to explain why the data maps perfectly onto a globe, as well as explaining the data.
Yeah. So all of that is optic. Yeah, because we're looking, etc. Everything I like to see.
But it matches the when you look at the flat surface, so I've asked quite a few people about. I've asked, okay, let's say we are entirely flat, with the Earth is a flat surface.
Hold on, mate, I ain't taking that one.
No, okay, sorry. The people I've spoken to.
There are people out there.
Yeah, so let's say that the Earth is...
All I'm saying is 11 is all I'm saying. But that's all. I don't see you know where I am.
I've asked quite a few people, then why are we seeing this data map so perfectly onto the sphere model? Why does it?
Could it be the celestial sphere? You know what the celestial sphere is?
I don't. That's not what I've heard of.
Well, basically,
Yes, no, I know what you mean.
Like you said he bent it round and then it worked, right?
Yeah.
So that is the celestial sphere, right? Yeah. Is it optical? Is the sphere optical?
Yeah.
You know,
No, it's
I'll go and get the thing for the auto level one.
I haven't really taken much footage, Bev, because it's just myself nowhere near like you. I'm going to grab it off you later on.
What have you got there, mate?
Continue recording. We're listening to him.
Okay, so much like I've said to Mark about how I don't expect our very different from the same point. If you're saying that what is your aim by taking optical images? What do you how
everyone's doing it for their own thing. I just came here for the
hey, it's a social thing, I think.
I've seen it.
I will say it's a shame it's not a nicer day because it is an absolutely lovely walk down this river. And you go down there, there's like small nests all over the place, they've got sheep. I even said if it's the other walk
Everyone says it though as well, don't they?
Everyone helps in the song. No, exactly.
Everyone refers to it as well.
Yeah.
It's just like, there's a disconnect.
Understand. I personally disagree. I get where people are coming from. Like I said,
You're not going around calling people idiots.
There's no reason for that. There's no reason for that.
No reason to deference.
Oh God, no. Definitely know that. I mean,
but that's what it's come to sometimes online. It's got a bit crazy, isn't it?
I think that I think part of the problem is that you get there's people on both sides of it who are the loudest people, and I think they tend to give a bad rap to the rest of it. And, I've had lots of really lovely discussions with people who disagree with me about various topics online. I did a video on sort of talking about
I think that's just a yeah, but is it a matter of like when it's said like that, it's almost like it's a matter of get these people to understand. I think do you know what I mean? That's
working together. I think that the evidence is very much on our side. So full start. I'm willing to. That's what I think.
sold a mile and you go into real life. It's a beautiful thing to have as a, you know, just to have some form of like understanding of where we are. Because whether it is one or the other, we still know a lot more than most people.
I've learned so much by because it makes you go out and go, well, why do I think this? And what? There is definitely an element of truth to the vast majority of people were told it in school, and that's all they've ever thought. And so I found it really interesting going out, doing some experiments myself, and going, okay, look at the results of these experiments, and go, wow, that for me, that really does solidify the idea that the Earth is a globe.
It's your proof,
yeah. But it's things like this. You guys go out there doing your things yourself, and so I've been trying to go out there and do things myself. Yeah, I don't get this experiment because while I understand what it's meant to show, I completely understand
I'll always be accountable, but what will be accountable to is to enter the hole. That's something will not ever be, in my opinion.
Well, that's, you've got refraction involved in that. The water level thing, I'm not sure about because. Let's assume, for the sake of argument, that the globe model is correct. Just for the sake of argument.
You can.
Yeah, no, that's fine.
If I don't.
No, that's fine. You don't have to. But if the Earth is curved, okay, and you have a water level that follows that curve, and gravity pulls towards the centre, your both ends, even if they're pointing away from each other and pulling towards there, will still be at the same height.
I understand that. I've already thought about this before.
So I don't get how it shows either way.
Right, well,
I mean, I found a way to it. Like, if you were to put a level in the middle and level it to see where the water levels, like, measure where the water levels go.
But how
place them where the water level.
Well, because the level is always level. Level. It's always perpendicular to the globe model to the pull of gravity. So if you measure it in the middle, it's going to be pulling that way. But if you measure it at the side, the curve around here, it's going to be pulling that way. But it'll show the same on the physical level. So it's like, how do you know if
you can't have perpendicular to a curve, though? That's the problem in geometry. There's a little bit of a.
You can have it to a point.
Because you guys,
not to the whole.
Yeah, you got a point. Right?
Yeah, sorry.
You've actually got horizontal down to a point. You guys.
Yeah,
that's your problem.
It's
you've only got a level here. You could have put a level there. You know, whether it's vertical or whatever. On the model, you know, no other horizontal or vertical can be.
No, that's how it works. But my point is with that is that let's say it is, and you measure, put the spirit level or whatever here, and it goes, yeah, that's perfect level, and you do it over here, and that's perfect level. We don't know whether it's a curve with gravity pulling down through the centre, or it's like
you can
this.
certainly think of it.
It doesn't show either way.
You can think of it like that.
There's so many of these experiments.
You got a pencil?
I
like a man. No, that's alright. No, it's fine. No, I was going to draw on there. But basically, what you got is you got. So this is one upstand here, and the water level goes to here. That's the 400 metres, right? Okay. That's my. No, I've got one then. That's what we did. Right, so the 400 metre level there. And what we did is on the 200 metre, we didn't put it up right. We did put one up 3. Yeah. So there's 3 in this section here. Okay. Yeah. And then this one missing, right? And this one. So uprights on the phone, which are 100 metres between them. So 1, 2, 3 there, and each of those were like within a couple of mil. There was fluctuation through temperature. But what a great way to figure out if that's on a straight line, right? Go home and like just get your pen out. Just, you can get your head around that. That's the way I believe it can be proved. Well, you should have a chair straight on.
Yeah. I think I might. Yeah.
That's always going.
Yeah. If the globe Earth model is right, that accounts for that.
No, it doesn't. It doesn't.
Does it not?
No, because
which bit?
No, right. Okay.
Sorry,
So
I
you've got
might miss
something.
Is it online? I can look it up. I'll look it up.
You can. But basically, so there's one right?
Yeah.
And this is the second one.
Yeah.
We've got 3, 400.
Sit in.
I haven't seen it done. I've seen the pictures of drawings, but I've not seen it.
Yeah, so we've got like, basically an overlap of 3 points in the middle. So if you've got like, so it's 600 metres overall distance. Yeah. 2 separate wall levels, and at the middle point there's 3 points in which they all have upstanding.
Okay, and those 3 are all.
And it's whether if they're all the same measurement, distance parallel. Yeah. You won't get a reading on the end one because that's irrelevant to us. And this end's relevant. It's only the 3 in the middle. And if they are parallel to each other, as in,
it would show that this one and that one are the same as well.
Yeah, you got it.
Yeah, we do.
Right? No, that's the geometric proof. Right?
That's over 600.
But we've got, guys that are now, thinking about getting 400 metres themselves, and then we could actually achieve 1600 metres with 400. Well, actually, it'd be a bit less than that because we've actually middle sector.
Do you know how much difference we've been predicted over that amount? How much curve?
I think they predicted there were some predictions on that.
How's it looking?
It's been going for 23 minutes now.
See, that's mad. That's that far down. It looks like the canal's going like that.
Yeah.
Doesn't it? It's that far down there.
The sun hitting the pole. It's making fluctuations.
It's all the way down there. Pylons, bloody hell. You can only just see them here.
From that, we realised that, so if you had a day where
Is that one right at the end there?
Yeah.
Jeez, that's nice quality, that as well.
Good bit of timing there.
Yeah.
Yeah, that's really
Of course, the water's rippling as well.
Oh look, you can zoom right in on it.
Oh, when we came down to do our solstice measuring the sun was a day like this, and we were like, clouds, come on, find a break in the clouds. And we literally got like a break in the cloud for about 30 seconds, pretty much like a minute before. But otherwise it was completely.
Have we done a zoom in and out on it?
Oh really? It's just been recording, so...
Yeah, we'll pull it back, then pull it back in again.
It is a shame actually.
So you can show how far away you are and that. And zoom back in. Remember whereabouts you were. It's turned a bit more way. Oh well.
Cool, this equipment.
Yeah, I'll keep an eye on where I'm doing.
He seems to have a reasonable chat. He's just really
Exactly.
He sounds it, yeah.
Is that the one you're looking from here?
Yeah, that's from literally.
How you doing, big man?
All right.
Good, good.
Oh, that one is 6 kilometres. So there's 1, 2, 4.
Do you know where the 2 foot? Oh, they're not up.
They're not up at the
Oh,
moment.
okay.
They go there, yeah.
Yeah, go and get his measuring stuff, and I'll shoot down there and we can measure.
Go ahead.
This is the height of this here, and then the height of that. So that's something. What's it look like for you guys? Can you see the sure.
So there's a number of things. They're slightly different sizes. But they're just
Right, so you guys can see that.
Well, that's what you saying there, where you put like 6
What I think we're going to do is get this. Keep my phone here. Well, we're just going to go and look at that.
You're going to go on where? Down there?
Yeah, we're going to check the height. You're going to check the height.
Let's hold it to the right a bit.